Hello, everyone. Good morning to you all. This is Group 47, and we come your way with the role of IT in chemical manufacturing processes. Today, we are looking at biodiesel production from algae as a chemical manufacturing process. This presentation provides an in depth look into the fascinating world of algae based biodiesel production. We will explore the intricate processes involved from cultivation to purification and highlight the numerous environmental and economic benefits that make algae a promising third generation biofuel feedstock. We will also look at the necessary basic input and output systems that will be helpful and needful in a chemical plant that is capable of producing biodiesel from algae. Join us as we uncover the potential of microalgae to revolutionize the renewable energy landscape and contribute to a more sustainable future. What is biodiesel? Biodiesel is a clean burning renewable and biodegradable fuel derived from natural oils and fats, offering a sustainable alternative to petroleum diesel. It is typically produced through chemical process called transesterification, where vegetable oils, animal fats, or recycled cooking greases react with an alcohol, usually methanol, in the presence of a catalyst. This reaction converts the triglycerides in the oils into fatty acid methyl esters (FAE), which is the primary component of biodiesel, and glycerol as a valuable byproduct. Some usefulness of biodiesel. For technological and industrial applications, biodiesel is used in transportation, buses, trucks, ships, and trains, aviation also, and in power generation, such as the backup generators and industrial boilers used in various industries. Again, biodiesel supports engine performance and efficiency. It offers a high cetane number which produces a better ignition quality, and it offers a superior lubricity and is less flammable too. To the environment, biodiesel reduces greenhouse gas emissions. It lowers harmful air pollutants such as sulfur oxides, carbon monoxide. As giving security to energy, it reduces reliance on fossil fuels. Biodiesel promotes a circular economy where waste oils, animal fats, and algae biomass are recycled. Its inherent biodegradability and non-toxic properties make it a more environmentally friendly option compared to conventional fossil fuels. It can be used in most diesel engines, as already said, with little or no modification, making its integration into existing infrastructure relatively straightforward. This versatility, combined with its reduced emission profile, positions biodiesel as a crucial component in the global transition towards greener energy sources. Why use algae for biodiesel? Algae offers itself as the promising source for biodiesel production due to its high efficiency, sustainability, and environmental benefits compared to traditional crops. It can be grown in non-arable lands and even wastewater, providing ready availability. It has fast growth rate and can be harvested continuously. This provides an abundant supply. It again consumes carbon dioxide and therefore helps to fight climate change. Lastly, it produces many valuable byproducts, including animal feed, biofertilizers, biogas, pharmaceuticals, and nutraceuticals. With the production of biodiesel from algae, we consider and prefer microalgae. So some microalgae that we use include Chlorella vulgaris, Nanochloropsis oculata, Bitriococcus brunnii, and many more. These have rich lipid contents. Now let's move into the algae biodiesel production process itself. The production of biodiesel from algae involves a series of meticulously engineered steps, each crucial for optimizing efficiency and yield. The process begins with algae cultivation, which takes place in large outdoor open ponds or controlled indoor photobioreactors, chosen based on the specific algae strain and desired scalability. Following successful growth, the algae biomass is harvested. This step is critical as algae cultures are dilute, making efficient separation challenging. Common techniques include filtration, centrifugation, or flocculation. Once harvested, the algae biomass must be thoroughly dried to facilitate subsequent oil extraction. Drying methods can range from energy-intensive spray drying to more economical sun drying, depending on local conditions and economic considerations. Oil extraction, the next vital step, typically involves mechanical pressing or solvent extraction methods, such as using hexane or supercritical carbon dioxide. The extracted algae oil then undergoes transesterification, which reacts with methanol in the presence of a catalyst to convert it into fatty acid methyl esters via the FAME, which is also the biodiesel, and glycerol. Finally, the crude biodiesel is separated from the glycerol and undergoes a purification process, including washing and drying, to meet stringent fuel quality standards. So there is algae cultivation, which uses photobioreactors or open ponds to grow specific microalgae strains, optimizing conditions for biomass and lipid accumulation. There is the harvesting, that is the separating of the algae from the growth medium using methods like filtration, centrifugation, or flocculation to concentrate the biomass. There is drying, which is the removing of the water content from the harvested algae biomass to prepare it for efficient oil extraction. There is oil extraction, which is recovering lipids from dried algae using mechanical presses, solvent extraction, or supercritical fluid extraction. There's the trans-esterification, that is the conversion of the algae oil into biodiesel by reacting it with methanol and a catalyst. Then there's the separation and purification, where the biodiesel is separated from the glycerol and impurities, followed by a washing and drying to meet fuel supplications. Necessary and basic computer needs of the company that produces biodiesel from algae. So let's get into the chemical plants, the various units, the various areas, and look at some input and output devices in the plant. Under algae cultivation area 1, we can look at input devices such as pH sensors, which monitor and maintain optimal pH levels for algae growth. We can look at dissolved oxygen sensors, we can look at temperature sensors, we can look at carbon dioxide concentration sensors, we can look at light intensity sensors. For output devices under this same area, we can look at automated valve controls, alarm systems. Again, under harvesting and dewatering units, we can look at input devices like the flow meters, turbidity sensors, and the weight sensors. For the output devices, we can look at the centrifuge or pump speed controllers, display screens, and others. Under lipid extraction unit, we can see input devices like pressure sensors, temperature sensors, barcode scanners. Under output devices, we can also see the safety alarms, automated valve controls, also under lipid extraction unit. Under trans-esterification reactors, we can see input devices like thermocouples, methanol flow meter, pH sensors, and output devices like automated dosing pumps, emergency shutdown systems. Under the purification and glycerin separation, we can look at density sensors, moisture sensors. Output devices like centrifuge controls, quality control displays can also be seen. With the storage and dispatch area, input devices needed are the level sensors, RFID tags. and output devices included are the automated filling systems and the printers. For our control room and safety systems, we can see gas detectors, flame detectors. Output devices also include the central alarm systems and the SCADA screens. Let's look at some few software needs of this chemical plant. So we need a process control software, which includes a supervisory control and data acquisition system, DCS software, and advanced process control systems. We need process simulation softwares like Aspen Plus for process modeling. We need laboratory information management system for sample tracking and results management. We need asset management softwares for predictive maintenance scheduling. We need enterprise resource planning systems like the SAP for business operations. We need environmental monitoring software for emissions tracking, waste management. We also need cyber security softwares for industrial firewall protection. One may ask, don't we need a network infrastructure in this chemical plant? Oh, yes, we do. A network infrastructure system here, we can look at a wired connection. Primarily, wired connection is reliable in the industrial setting. It's more reliable for critical control systems, unlike the limited wireless, which is for the mobile devices and other temporary connections in the chemical plant. We can adopt a network scope like the local area network for the plant's operations and some possible campus area network if we have larger sites. A recommended topology can be the hierarchical star topology, which is for the central core switch in the control room, distribution switches in each major area. We can also have access switches for local device clusters. Again, so we can have redundant ring for critical areas like a fiber optic ring connecting major control areas. This is to ensure continuous operation if single link fails. We can also have segmentation where separate virtual local area networks for control systems, business networks, and other safety systems in the chemical plant. We can make use of industrial protocols like the Profinet process field network or Ethernet for field devices. Additionally, we should have an uninterruptible power supply for network equipment, industrial grid switches and routers for harsh environments, proper network documentation and labeling, regular network performance monitoring. So these are some things that we need for our chemical plants, the input and output devices, and some network that can be adopted. Applications of biodiesel. As already stated, it can be used as a transportation fuel, a heating fuel, a lubricant additive, a power generator, and under marine and agriculture, we can use it to power marine engines and agricultural machinery, reducing the carbon footprint of these industries, and it's also an environmental clean up. Benefits of using biodiesel. Always remember, biodiesel is biodegradable and non-toxic. It minimizes environmental harm in case of spills that can even degrade naturally without persistent toxicity. It also has high engine compatibility. Always remember, there is so much usefulness for biodiesel. Thank you very much for staying through with us. Have a nice day.